Sorry for that brief interruption, but to continue on with our discussion of how the Ctis system pneumatically works. Yes, so we left off talking about the manifold and then ordering the correct part according to the vehicle's nomenclature. So that's essentially it in a nutshell. One thing to remember, which we will cover when we go over the electrical, as I was saying, that the system doesn't monitor each individual tire. It only can monitor each one axle at a time. But to fill any of the tires up, it also does not have that capability. It doesn't even have the capability of filling each individual axle up. It has to send air, just from the way the circuitry, pneumatic circuitry is designed. It has to send air to all of the wheels, even if, say, one is flat. And that's just the way they designed it. I don't know why. It's how they did it. But it'll be evident, say, if this wheel is flat and you're filling it up, you're in run flat mode, you might not hear any air coming out of this purge valve because it's all going into this tire, but you may hear air coming out of your back valve or your back two valves because these tires are filled up. They don't need air that way. That being that whenever that cycle we talked about, how the ECU functions in cycles, it will cut off air to the system, and like I said, the air will go into this tire, but the air that comes back this way will just simply be purged. That way, it's sort of a double acting relay. Whenever the air is purged, the diaphragm closes and air is removed from this lower half of the purge circuit, but air remains in the manifold. So, moving on. That essentially is how the Ctis system works. Another thing I will discuss that I personally have not tried, but it could provide some remedies depending on how severe or how severe the status is of your Ctis system. There is a regulator just after the wet tank sensor that I imagine can be adjusted. I have not adjusted it myself, but you may find results by adjusting it. I'll just say if there's a little bit of moisture in your system, you may be able to adjust it and get your tire to inflate, but we'll go into all of that once we talk about the electronics. So everybody's favorite, electronics. So this is essentially what goes on inside the ECU, inside the manifold. In theory, this is not exact. It's probably, I've drawn this sort of in an analog solid state fashion. I'm sure there's processors and ones and zeros and all that type of garbage going on with inside this ECU. But for presentation purposes, this is essentially how it works. Like I said, your mileage may vary, but if you look at it, it's essentially doing the same thing. So it all starts with ignition. I have foolishly omitted the circuit breaker. So power comes from the ignition, goes through the circuit breaker, through PDM 3, I believe it is, and down to the ECU. Once at the ECU, once the ECU has power, there's a ground strap what is the connector? P110, I believe, is the connector that goes into the ECU, and there is a ground that comes off and it grounds directly to the dashboard or the center console or whatever you please. So ignition power comes in here. Well, not in here per se, but the ECU receives ignition power via PDM3, and the circuit breaker are allowing. But ignition or power is carried, of course, as I stated earlier, to this 125 wet tank pressure switch. And again, it's as simple. It's open or closed. Whenever the tank gets up to 125 psi, switch closes, sends a electrical signal back to the ECU. So, what really is sort of going on inside the ECU is once that switch closes, it also sends current coming down here to, I've made my mistake of drawing each individual wheel in here until I remembered that it only works for each individual axle. So there really, again, there are only going to be 2 sensors or 3, again, depending on your model of pressure switch in here. But nevertheless, it carries power to said pressure switch, again, for how many axles you have, 1, 2, or 3. How these pressure switches work, it's the opposite of how you think they would work. You think the circuit would close whenever it is up to pressure, but that is not the case. These switches have to work in opposite because we are adding when we're below. So we need something to happen whenever we are below instead of something to stop whenever we are above, essentially. So these switches or sensors or whatever are, of course, in the manifold, and they're directly connected to the air circuit. So again, whenever the air circuit is not up to pressure, the sensor or switch closes. Okay, it closes. Whenever it's up to pressure, it's open. See how I mean? It's sort of backwards. So the switch closes. When it closes, it sends that power that's coming in it's coming back to the ECU, and it's then working a relay to then shut this switch, which is the main supply valve switch, which is it's the main supply for air coming into the manifold. And of course, everything goes to the ground, again, which grounds to the dashboard, or again, console, whatever you prefer. So again, that initial startup, whenever you've drained your tanks, obviously when you drain your tanks, all your air is going to come out. So whenever you first start up and your tank is filling, once it's full, these sensors in here are obviously not going to read, which causes that first cycle because this is empty because you drained your wet tank overnight. Whenever it's full, it's going to send that first cycle, send air through, and then purge. It'll be up to temp if your wheels are up to proper pressure, and then it will stop, and that's when you get that solid light on highway mode or whatever mode you happen to be in. That light will blink whenever it is transitioning or filling or whatever. It means it's not fully in that mode, it's transitioning. And of course, another thing with the ECU is the 5 code light, the dreaded 5 code light, which means that the system was not able to get up to pressure, essentially. For whatever reason that could be, it's not in inflation mode, which I've seen. You have to go in with an MSD and set the thing to inflation mode. and then it was fine afterwards. It worked perfectly. Or you have to pull the circuit breaker and sort of reset the ECU. But electrically, that's essentially how this works. Like I said, it's not I'm not an electrical engineer. I have not looked inside an ECU at the circuit board. I can't even tell you how circuit boards are routed and any of that. But for visualization, this is how it essentially works. Okay, so now let's get to the fault. The faults we can have with this system. The most common, and if you're struggling and you just can't figure it out, what it could possibly be. Because if you think about it, really, it's a limited number of components. It's a relatively simple system. It's just that, again, the manual doesn't really do a good job of explaining how all these components work and how they relate to each other and essentially how they operate. It just focuses more on the electrical, which is fine, but at the end of the day, the mechanics really suffer because most of the time it's not electrical because all this is cooped away inside the dash and it's mostly mechanical. And of course, a big factor that comes into this is user error. Say you forget to drain the tank overnight, stuff freezes, and which is essentially what I have on the fault I have on a current truck that I'm working on. Last year, truck was left out with air in the tanks. The air dryer and purge valve assembly had to be replaced because the purge valve froze open and essentially messed it up. So that had to be replaced. But when it was replaced, I guess I wasn't thinking or whatever that moisture or slash ice or what have you could have gotten into the system and it caused the fault what I'm having, which I'm having right now, which is some gunk is in remember that regulator I talked about? It's sort of in that regulator slash that, and like I said, it's old, it's exposed to the elements. Sort of in that section of the system. So with that being there, what's happening, and it's causing this vehicle to have the deflating tire fault, is with that being gunked up, it's not able to send that initial supply of air through. The sensors pick up, well, they don't pick up, but they don't close, or we'll just, for simplicity's sake, they see that this line is not up to 125 psi, so they remain closed, which engages the supply valve. Supply valve opens, sends air through. But of course, because supply valve is being supplied by a supply line that essentially is not able to achieve full flow, it's enough flow, I think, well, my theory anyway, it's enough flow to open these diaphragms, but not enough to fill the tire. So what ends up happening is pressure from the tire ends up being purged, because remember, it can't come back in here because this is a check, but it ends up being purged because it's losing more air than it can supply, and it comes out this valve and just goes away, and eventually tires get deflated while it's running. Now, when the vehicle is off, that's definitely a hub seal problem, but while it's running and it actively deflates the tires, this is a possible cause. Another possible cause that could be caused by this is if this, well, say your tires were already flat, but they're just not inflating, it could be caused by a bad valve. Easiest way to check the valve is when it's going through its cycle, just listen to see if air comes out. But if air comes out and your tires are not inflating, then it's most likely you have a blockage back here. The manifold could definitely be at fault as well, but it's really not that common because it's It's not like these components down here. This is up in the cab where it's warm. Maybe if you had water ingress or something, or a solenoid valve or a sensor go bad on you, I can see that. But that would just cause your tires to not inflate. It wouldn't actively deflate your tires. Yeah, so that's the fault I'm having. So that's two faults we covered. We covered the seals being bad, and we covered a blockage back here. Again, if it's just throwing a will not inflate code, I've seen these ECUs burn up. It's probably not as common, I don't know, but I don't think it would be as common, and there might be a good bit of misdiagnosis, hence the reason I'm making this video, of two other things that could be going on in the system, just for you to consider more options instead of just replace the ECU and see if it fixes it. Sort of trying to correct that just throw parts at it mentality that I see a lot of. So yeah, in conclusion, that is how a Ctis system both works pneumatically and electronically. Like I said, I decided to make this video to sort of clear up any confusion that anybody might have, and just to inform the general populace working on that has issues with the Ctis system. I hope this helped, and have a good day.